Hi, everyone. Welcome. I'm Inessa Pawson, Open Source Program Manager at OpenTeams and Head of Open Source Architect Community, the host of today's event. The OSA Community connects software architects and seasoned technical leaders who are passionate about open source technology. To learn more about the community and how to join us, visit our webpage. I will put a link in the chat shortly. And a few words about OpenTeams, the sponsor of the OSA community. OpenTeams bridges the gap between enterprises and open source communities, facilitating collaboration, adoption, and optimization. And on to the topic of today's event. How do you prevent a tragedy of the commons and develop an ecosystem where maintainers of an open source project can thrive while continuing to support the community? For this conversation, I've invited Chris Rackauckas, the VP of Modeling and Simulation at JuliaHub, to talk about JuliaSim, a product built by the developers from the Julia SciML open source organization in close collaboration with the Julia core compiler developers. And a few words about Chris. In addition to being the VP of Modeling and Simulation at JuliaHub, Dr. Chris Rackauckas is the Director of Scientific Research at Pumas AI, co-PI of the Julia Lab at MIT, and the lead developer of the SciML open source software organization. He's a recipient of the US Air Force Artificial Intelligence Accelerator Scientific Excellence Award for his work in mechanistic machine learning. Chris is also the lead developer of the Pumas project and has received a top presentation award at every ACOP in the last 3 years for improving methods for uncertainty quantification, automated GPU acceleration of nonlinear mixed effects modeling, NLME, and machine learning assisted construction of NLME models with deep NLME. There are quite a few other achievements that Chris has on his resume. There is a website that I'll share a link and please check out. And with that, please welcome Chris.
Yeah, thank you very much for the kind introduction. And yeah, I think that I think that this is the right community to give this talk because I think that the stage here is really not about the math or the science itself or the applications. These are other talks that I give that you can find on YouTube. But the topic today is really more about how do you build a sustainable open source ecosystem by incorporating open source and some things that you're doing with companies, right? And this is a question that I get all the time because I'm part of the Julia community. In fact, I think I can say that I have the record for the number of packages that people have created, probably the number of packages in the top 100 Julia packages I probably maintain. I probably like 20 or 30 of them. So, in terms of open source work, I'm really out there in terms of open source, but my day-to-day job, I always say, oh, it's not the open source, but it's quite related, right? And so I never really haven't given the chance to be able to describe this whole idea of how the Julia community has really come together and what a lot of its pieces are. Right. So the grand overview timeline is this that I want to kind of go through, which is that, we have the Julia programming language, which is an open source community that has about 1 million developers using it at this point. Right. So Julia is a rather new language, but when you think about open source community of users, 1 million users is pretty substantial, right? So we have the download statistics and we know the monthly downloads to be able to know when we release new versions. This is about the number that we're seeing over time for people in each new version release, right? So that's a substantial open source project. But how do you sustain such a large open source project? Turns out that there's many entities involved, right? And the main player entities here are the MIT Julia Lab, which is where the Julia language was first created. Right, the MIT Julia Lab is Alan Edelman's lab at MIT, and I'll discuss exactly what goes on there and how that's all related. But then we also have these pieces such as Julia Computing, which has been renamed to JuliaHub, and Pumas AI. And I'm going to give the whole story about how all these pieces come together to be able to show you how why we've created these companies, what kinds of pieces are closed source, and how it's been developed as a system that actually influences and improves the open source in the long run, right? So the conclusion that I'll have here is that by making the right software into products, we have greatly expanded the open source community, right? So by making the right things closed source, we've been able to do a lot more open source. And so I think it's rather unintuitive kind of thing. At first I thought, oh, you really championing open source, everything should be open source, right? But I kind of have changed my view on that over the years, and and I'll be able to explain to you with very concrete details as to why that's the case, and what we've been able to do, and maybe some lessons learned, so you can take it to your own, organizations, right? So I'm going to kind of, this is the grand overview, but let me now kind of walk through that timeline. So first of all, what is the core topic of the open source software that we're talking about, right? I want to set the stage for what, I don't want to go too much into the mathematics, but I want you to understand a bit the topic that we're discussing, right? The topic here is about performance in languages, right? So, what is the Julia programming language? If I could have one slide that tells you what the Julia programming language is, okay, there's many things that you can say, but the one thing that a lot of people like to gravitate towards it for is the fact that it's a high-level programming language that is also fast, right? If you look at the x-axis or the y-axis here, this is a great plot that was created actually by the Chapel community. So the Chapel programming language people created this plot, and I thought, it looked rather good for Julia, so I kind of put it together here. This is the execution time for some benchmarks from the benchmarks. I think that it come from the benchmark games repo. So the higher it is, the slower the slower the code runs. But on this axis is compressed code size. So this is the simplicity of the code, right? And the point of Julia is that as you go to the left here, then it takes less code to write something down. So you can see on the left you have these high-level programming languages, things like your Python, Ruby, MATLAB, these things where you can very easily write things because the language is expressive, right? And then as you go further down, you have faster programming languages, things that are closer to the metal, things like C, Fortran, right? But what you have in the bottom left here are things that are simple to write, but are also fast to run. And that is in this space where you find Julia, right? So Julia is this programming language that has gotten this popularity because it has this property that it can be high level, like Python, but also run as fast as C, right? Now, that's the full programming language in this community, and there's lots of other things to say around multiple dispatch. What I do in particular is build a lot of the numerical tooling there, such as, for example, differential equation solvers. So, differential equation solvers are things like ordinary differential equations, differential algebraic equations, these things that you find in terms of, if like ODE 4 or 5 in MATLAB, or if like the SciPy has ODE solvers as well, right? These are these core utilities for numerics, and specifically for doing things like physical modeling, chemical modeling, and physical modeling, chemical modeling, biological modeling, you name it. Most physical laws are expressing differential equations or differential algebraic equations. So a lot of my open source work and a lot of my research work has been along the lines of how do you develop new fast differential equation solvers? And we gravitated towards the Julia programming language because, well, it's the programming language that's supposed to be fast, so it's a nice foundation to both write the solvers in and use them, right? So in a lot of other communities, for example, in Python, a lot of the solvers that are built into, say, SciPy are written in Fortran, and then there's a Python interface to them, right? But what we're able to do is we're able to say, oh, we just write the solver and boom, it's ready to go. And we're able to demonstrate that a lot of our new solvers are actually faster than the original C and Fortran ones. And that's a whole topic in, numerical differential equations. That's another talk that I give. I'm not going to talk more about, what are the methods here. But I think that the point that I want to kind of emphasize is, we do a lot of this work on, fast differential equations. How do you do physical simulation as fast as possible? How do you make more use of GPUs? And this is our core open source software then, yeah. These kinds of being able to show people like, hey, look, we can improve the way that we do physical simulation, and here's open software that you can use in your own simulations. And here's things that work with GPUs that's going, faster than JAX because it's using all kinds of kernel generation tricks. And it's for differential equations, nonlinear systems, linear systems, nonlinear optimization, in numerical integration. Like this is the space that we work in. So if you think about, like SciPy or MATLAB, these kind of core libraries that have these functionalities built in. We're the ones who are building these core pieces for the Julia programming language, but we also are, numerical analysts, and our research is in new methods for this. So a lot of what we do is develop new methods and show that these new methods give performance by implementing the most performant version that we can, and then showing that it's faster than the original C and Fortran kind of thing, right? Now, a lot of what we also do as well is this thing called scientific machine learning, right? The name for our open source organization is SciML, because what we do is we say, we have all these tools for traditional physical simulation, which you represent as optimization problems or differential equations. We take these models of things like, if you think about, Newton's laws of general relativity, these are differential equations. You can take those and you can mix those with machine learning database methods. And, again, this is an entire topic, and exactly how that works, not really the topic of this talk, but what we do then is we have these techniques that where you can mix machine learning with differential equation modeling to do things like discover the equations you didn't know, and do things like take Newton's equations plus data about how gravitational waves work and data about black holes, and use that to discover how would you correct the equations for relativity automatically, right? So if you think about SciML, then it's a set of tooling that is, that's able to do a lot of what you think about like as, MATLAB or SciPy, these core numerical tools, but in ways that are all connected and usable with the world of machine learning. There's one set of research that is just how do you do the numerical things as strong as possible, as fast as possible, as robust as possible. And then there's a whole other set, which is now what's the right ways to be able to connect this with machine learning? How do you do automatic differentiation and backpropagation, all that, right? So that's who we are as a, that's who basically I am. This is my research over the last, more than 10 years. So over the last decade, that's the stuff that I've been building. And the SciML open source software organization then is the organization for for all these packages that we've been developing. Now, how do you actually describe this? Well, here's a slide that I took from the State of SciML talk at the last JuliaCon. It writes down a whole bunch of different numbers, but the way, what I want to kind of highlight is it's not a small organization by any means, right? If you think about, SciPy and such, I believe it had like, 20 active contributors. If you look at what we got going on with the SciML organization, we got about 100 repositories. A lot of them have multiple packages in themselves. So we have about 200 Julia packages, more than, I think we're now at almost 22,000 GitHub stars across the organization. More than 100 monthly contributors, about 20 core maintainers who are there every single day. We have 5 to 10 students that come for each summer, which is, if you think about the normal organization and NumFocus, it's about 3 students. And so we're kind of, we have a pretty large organization that's actually doing a lot of this work and integrating at this point. And then I'm the, that BDFL who is stupid enough to kind of say, let's work on all these repos at the same time. And that so what I'm going to describe a little bit about is, this is a pretty robust organization, right? I think that most people, if you know the stats of like, for example, like how SciPy or NumPy works, they'd be jealous about having, this amount of stuff. And you might ask a question of like, how did this open source software organization, especially because it's in Julia, which is, a newer language and stuff, how did it get to this, level of robustness in this community? And what I really want to discuss is the community building efforts that we've actively done over the last decade to be able to reach this amount, because it isn't something that's come just organically or randomly. It's something that we've really actively worked towards. So the SciML organization, right, to kind of give a flavor for it, right? When I say that there's 200 packages, what I mean is that there's certain tools for building models, like, so if you know, like Modelica or Simulink like tools, there's one branch that's all about that. There's tools for analyses like uncertainty quantification and bifurcation analyses and identifiability analysis. There's other branches for optimization tooling, other branches just for the simulation, the differential equation solvers. We have other numerical branches around, nonlinear solvers, interpolations, and also a lot of tools for, reservoir computing, which is in surrogates and machine learning. And all of this kind of comes together as one piece, which is all integrated. So that's what the SciML organization looks like. It's about 100 people just kind of slamming on all these codes together. with. I think I can kind of, and we're able to say like, oh, we have a lot of performance, we're always very performance focused. So this is like a summary slide I give a lot of the time. Where like, oh, we do this many times faster than this Fortran method and this Python thing. And, so it's this set of packages, all these kinds of places, but really looking at performance across the board and making sure it all works with machine learning, right? So how do we get here? I think a large part of this is that the SciML organization, you can say, is somewhat its foundation is the MIT Julia Lab, right? And I think that's a thing where a lot of people who look at the Julia programming language and it goes, what's its bedrock? They'd say it's the MIT Julia Lab. So let me describe a little bit about what this is, right? So the MIT Julia Lab is actually the lab where Julia was created, right? So the four people who created Julia was Alan Edelman, who was the PhD, the professor right here in the middle, who runs the lab, and there's three postdocs that he had at the time: Stefan Karpinski, Viral Shah, and Jeff Bezinson. Well, Jeff Bezinson, I think, was actually a PhD student, where the other two were postdocs. And so in this lab, the three of them together with Alan created the Julia programming language. And so the first batch of people who then came next in the MIT Julia Lab were all people who were developing the core standard libraries and numerical analysis systems, and the core math libraries. And then there was a next batch that created a lot of the first packages. And then there was a next batch which had me and create a lot of these, deeper numerical tools. And now we're on to batch 4, which is now working a lot on new tools for things like climate modeling for neuroscience, and a lot of more applications, really expanding out what Julia is used and is capable for, right? And if I'm to kind of show like, well, what does that actually look like at a concrete level, right? I can go, oh, here's the current people that we have within the Julia Lab. You have, for example, Alan, who runs courses with Julia, the core linear algebra course that is required for everybody to take at MIT. That's actually run in Julia, and he writes all the lecture notes. He trains people on this, but also a lot of other online training materials for Julia, like the critical thinking course that he ran with, which got, for example, 3 blue, 1 brown involved, right? A lot of the places where people learn about Julia, that still comes from Alan Edelman himself. He's written a lot of these things. You can see that I'm in here, and I maintain a lot of my research on new methods for solving differential equations. That part that goes out in the open is done as part of this MIT work. And you can see that we have a lot of these students involved, right? So, for example, Avik Paul here is one of our later stage PhD students. He built and maintains one of the main deep learning libraries there, and he also maintains a lot of the packages in the SciML organization. He's one of our, when we say we got 20 maintainers, this is where his day job comes from, right? Creating new methods and such. He's part of the MIT Julia Lab, and we fund him to be doing this, right? But then, we have, for example, a younger student, I think he's in his second year now, who's now becoming one of the new maintainers to symbolics.jl, with his work being research in new methods for improving symbolic computation. We have someone working on neural Lyapunov, which is, if you know physics-informed neural networks, it's a library for doing Lyapunov analyses and control stability analysis using neural networks. Very cool project that you might not have heard of this repo before because it's not quite released yet. But if you go check it out on GitHub, you can see it's already kind of in that development stage. So the MIT Julia Lab is really kind of a nice place for people to create new projects, try new ideas, and a lot of it's research focused, right? Because it's very, based out of an academic setting. So, there's more students, and all of them are all these are maintainers and contributors to the packages. Now, I'll say that, I didn't actually list every student here because I want to just focus on these are the ones that are really strong contributors to the open source. We also have some other students that are not doing as much open source contributions, but are doing, other research contributions in the same places, but not as software focused, right? So the MIT Julia Lab kind of has this mix. And you can see, for example, in last year's alumni that, we had, for example, the person who created Catalyst.jl, which is one of these modeling packages in SciML. Frank is still a maintainer of many of the SciML packages and differentiation packages. The creator of Symbolics.jl was here. The creator of all the HPC, parallelism, and GPU stack tools and Enzyme.jl, that was Valentin, who just graduated last year, right? So you can actually kind of see the interesting thing that when I point out all the alumni, these are the packages that right? Because at a later stage of their PhD, they had the 5 years to build it together, and really kind of become a strong contributor to the open source community. Whereas a lot of these other things are kind of like, oh, those are new packages and such. You don't know the students who are here as much just because they're in their earlier stage. And so this shows you how, an academic lab can be, a catalyst for a lot of open source projects. But it also, in the same picture, is showing you one of the major downsides to, you have an academic lab be the source and foundation of the community. Because if you think about it, me and Alan are the only ones that are there for more than 5 years. The moment someone becomes really productive and they have this huge library that everyone's using, that means you're out of your PhD position, right? Like you're the moment that your work works, then that means you write your thesis and you're done, right? Which is like, okay, well, how do you keep open source going, right? So I think so the MIT Julia Lab shows you a lot about how there is a lot of good stuff, and a lot of good open source is centered in a academic lab, right? If you go to most, NumPy, SciPy, Python, all these, right, you'll find that a lot of these things, you have major contributors who are from academic positions, right? But the ones that are kind of stable, the maintainers who stay for 10 years, they tend to be the professor, because these are the people who have a position for 10 years, right? Everyone else does not have a position that long. And so one of the difficulties with centering an open source organization on, and a community on academic labs, is the fact that academic funding requires a lot of work and is naturally transient, right? Most of the positions have time limits. In fact, if you keep a PhD student for like more than 7 years, you've ruined their career. Right. So, you don't want to, so like, oh, I want them to have a position so that way they maintain the software for 10 years. They're being underpaid, right? Because a PhD student's not getting a full industry salary or anything. They're not going to be there for more than 6 years. So, by definition, all the funding that is going to these academic positions is transient. And it's also a lot of work for all this funding, right? For if you think about it, like if you write what's known as like a pretty big grant, right? Like a lot of grants are about 500,000, some of them are 3 million. University takes overhead of more than 50%, and then you must fund the tuition. You also have to pay the tuition for the PhD students, right? Because they're not paying tuition. So it's you 50% of it's gone to the university before anything else. Then you pay tuition, then you pay healthcare, and then you finally pay their salary. And so like a 3 million grant might just be for one PhD student for their 5 years, right? And so each of these grants that you're writing are 30 pages, and I think the average acceptance rate now is around 17% in the United States. And so you can think about how many grants you have to be writing to have, most academic labs are not the size of the MIT Julia Lab, because most do not write a grant every 2 weeks or so, or whatever we have on average, right? Like this is a very abnormal already. And it's abnormal because we have a lot of collaborators that we work with. Like a lot of the grants, we don't have to write the full thing, because, for example, if someone says, oh, I'm using Julia and, I want to get more work done on modeling toolkit, let's write a grant that's half modeling toolkit and half climate modeling, right? That's the majority of Julia Lab grants, and a lot of what we do comes from that. So if you have any ideas and if you want to collaborate with us, always happy to talk grants. We have a whole system, like we have to have a factory going through to keep this alive. But then, yeah, this kind of shows you that, the moment that, you are funding the students for their tuition for the first few years, they're actually doing coursework. And so, some of the time is actually like, oh, I can't maintain this package because I need to do my homework. That's a real thing in this setting, right? And everything that has to be worked on has to be justified in terms of scientific merit. It can't just be, oh, the software has bugs, so let me make it better, right? You need to well, but I also need a new algorithm. So I fund you to make the new algorithm, but on the weekends, can you do the bug fixing? There's this kind of weird situation of the bug fixing is what you really care about in an open source setting and what a lot of contributors care about, but you'll never actually fund that you only fund the novel parts, right? And so there is a lot of good that happens from academic settings, but what we found over the years is that that's just a very hard way to keep a long-term ecosystem alive, because what you really want to be able to do is say, hey, look, you've become such a good maintainer with these packages. Let's pay you to just continue to do something where, yeah, maybe you have to do something as a day job because open source is not, earning money, but how do you keep how do you have a position where you can continue to maintain these packages? Because if you just go off to some company where, they might say, have a policy that no IP is open source, well, now we lose someone who's one of our bedrocks of the ecosystem. So what do we do, right? And so let me then tell you a bit of the story of Pumas AI, which is the first startup I was involved with, and to kind of show you, and for this case, how that helped build out the Julia and SciML open source communities, right? So this kind of comes in the timeline here of I was starting to build the first components of what became Pumas during my grad school, right? It was something I was working on, the differential equation solvers, and you'll see when I describe what it does that it's the differential equation solvers plus plus. It's something that's built on top of that. So I was able to kind of showcase, oh, hey, look, I can do this nonlinear mixed effects modeling. We can do pharmacometrics so well. We went to a lot of these scientific talks, and we actually were saying like, oh yeah, maybe we'll, when we finish this up, maybe we'll open source this. Maybe, that would be the right way to do things. We actually had it open for a little bit, but it didn't work out right. And so actually then in 2019, it was converted into a company, and that made it to be something that it was really successful. So let me kind of talk about what this is all about to really kind of set the stage for why having, again, I have open source like 200 packages. Why this one in particular didn't end up open source, even though it was kind of the first intent. So what is nonlinear mixed effects modeling? So nonlinear mixed effects modeling, when you walk into the clinic, the clinician is able to get certain measurements on you. These measurements are things like age, height, sex, and weight, and these are known as your covariates. You take a model, you take your covariates, and you put them into a model. This is a structural model which coalesces all the different covariates with some things known as the random effects and fixed effects, which then become the parameters of a differential equation. If you didn't understand that at all, let me just say that you come up with some mathematical way of being able to figure out how people with different weights, how it will affect the drug dynamics in their body. So that way, someone who weighs more might, release the drug from their kidney quicker, and so therefore they might need a larger dose, right? And so the purpose of nonlinear mixed effects modeling is to find out what is the optimal dose for the population. And should, for example, male and females be dosed differently for this drug, or should they be dosed the same? Is there an optimal dose for the whole population, or do I have to split the dose because it would be toxic for some subsets of the population, right? So nonlinear mixed effects modeling is all about this. And again, the research that I do is how do you solve ODEs as fast as possible, and how do you find parameters and fit these ODEs as fast as possible. You can see how this exactly falls into, oh, this is the stuff that I do. I think I could do this really well. And so what we did was I went to these conferences, ACOP and everything, and we showed that, hey, we could do this process so well. And what happened was, we talked to like these large pharmaceutical organizations, and they'd say, well, we can't actually adopt it until, like, okay, we can't adopt this because you need to get this FDA verified. Oh, how do we do that? Well, you have to go through the regulatory process. You have to pay a few $1,000,000 to be able to cover the cost of the evaluators where they do that. They're like, wait, I'm a grad student. Where did I just come up with a few $1,000,000 and all this? Like, where does an open source organization do all this? And they're like, oh, and then we want to make sure that you can support us, yada, yada, yada. And the other things that we found out as well was, and the other things that we found out as well was that for this kind of very specific kind of topic, right? The number of people who would use this software, right? They tend to be in these companies. They'd also say, oh, and also I can't really contribute anyways because my company has a policy that says like, this is proprietary data or the proprietary model. So it was a group that was starting to ask for a lot that also is very clear that they were not the kind of groups that could easily contribute to an open source project, right? So what do you do? What we ended up doing was we said, okay, let's actually build out this full pharmacometric piece as a closed source software on top of the open source software, right? We don't need to have like all of the, the differential equation solvers, this research on how all this, and this can stay as our open source foundation. We can use it, but what are the needs that the actual clinicians are asking for? Is not this kind of stuff, right? All the extra things that are like, I don't want to do that because it's not the fun part of the work, right? keep the fun part of work, the research and the open source, but what are all the other things? It's, readers for specific data sets, because they're like, okay, our standard clinical trials give you an NM-tran data set. Can you support NM-tran files, right? Specialized tooling, like, okay, for bioequivalence models for generic drugs, you need to have exactly this analysis, and your report should follow this thing, like our company has this color policy. So, can you make it so that way you generate reports that match this color policy, yada, yada, yada. As I explain all these things, you probably think, oh, that's not what I like to do in my free time, right? But that's exactly what you need in order to make it so that way it's useful to these companies to be able to be used in an actual FDA filing, right? And so right there, that kind of over time, we just realized that this piece right here, all the functionality that that gears the differential equation solvers towards being able to be useful for real FDA filing. This is the piece that we can have as a proprietary software, and this became the foundation then of Pumas AI. This is the Pumas .jl nonlinear mixed effect system that then kind of spawned this business around it, where we can then actually fund through the business and the software, the FDA to be able to, we run trainings, we teach the FDA, we can actually make it compliant with all the regulations, and then have a support team for the companies to be able to use it, right? And we've been quite successful in that aspect. In 2020, the director head of pharmacology and pharmacometrics at Moderna actually mentioned that the core tool that they used for example, with the Moderna vaccines was Pumas, right? And if you think about this timeline, the company was created in 2019, kind of ended up being the perfect time, because what happened in 2020 was COVID-19, which then the first drug that Moderna ended up using, they were using Pumas to be able to get this new analysis tool with its new performance to be able to get this fastest vaccine out there, right? And so that's the story of how Pumas has actually worked out to then become, a company that's able to build off of these open source tools, right? But then I think the other effect is not, how do you build off the open source tools, but what effect has this had on the open source community, right? Because now you might have, I've actually had some people go, oh, but aren't you so into open source? Like, hasn't making this closed source ruin your open source ideals? I go, no, 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 no. Because look at what's actually happened from this, right? Because, what we get with Pumas is that the industrial users, again, because of certain policies within their company, we tried to make it open source at first for a bit, but they for many reasons they couldn't contribute. Regulatory processes, they say, oh, we can't use the open source software because we have this regulatory concern and we need a company that backs it in order to figure that out. Right. But all that aside, it basically then gave us a funding mechanism for everyone who actually wanted to work on these differential equation solvers. We now had a place to hire them to when they graduated from, because again, you go back a few slides, what happens to all these people when they graduate after they start to be contributors to the library that, are so good? We now had a company where you could just say, hey, you like to work on the, using these open source tools and everything. Well, you're the one who knows how to use it better than anyone else. We have a company that requires the software. Do you want to keep doing this, right? And this actually then is very good for the company because the open source, the hires that you make, you already know how they're going to work. You already know that they're going to work in large teams. They already know the entire software stack and all of its dependencies. And also one of the interesting things that we learned was that the free work is usable, right? What do I mean by free work? Well, there's always going to be random contributions to the open source ecosystem. And so one of the things that happens then is if you hire someone to Pumas and they're also working on the differential equation solvers, right? Someone might make a pull request that says, hey, here's a new method that improves something. And then might make a small tweak to it that says, hey, this will be useful in Pumas if I do this. And it turns out that, it's useful in Pumas if you make this change also means it'll be useful in astronomy, in chemistry, yada, yada, yada. And so they just have a bigger view of like, oh, here's how to make these applications. But then also means that, Pumas benefits because the main maintainers of these libraries then understand and are a part of the process for the code changes. So people building off the open source then have very strong people who know their entire dependency stack and then just ends up building better software. And so, and what is the concrete effect of this? I just kind of looked through this earlier today and just said, okay, how well let's show people like who have we hired to Pumas and what are they working on in terms of the open source, right? So each of the people that you see here, this is not the entire Pumas development team, but this is the subset of the Pumas development team that also come from a strong open source background. And you can see, for example, one of the people who's also a steering council member, so one of the top contributors of the SciML organization. He's been a product engineer at Pumas for a few years now. He's also one of the top maintainers of Turing.jl, which is the Bayesian fitting library, right? Someone who works on the LaTeX engines and Catalyst, people who work on PDE libraries, right? Pumas is not a PDE thing at all, but a lot of the Julia PDE libraries are actually, they do those open source projects on the side where they work on their day job as also, using a similar software stack on different problems. Now, I mentioned, for example, that we had to do a lot with report generation and getting FDA compliant results. This is a lot of very fine-tuned, making visualizations that match very specific regulatory needs. And so we actually have hired some of the people who work on the plotting and visualization libraries, right? So one of the top 3 contributors to Mach.jl actually is, his day job, day to day, is working in Pumas. One of the main maintainers of the package ecosystem repository. So if you think in terms of the Python ecosystem, this would be like PyPy, or in R, it'd be like CRAN. Well, the person who runs those kinds of systems in Julia, one of the main maintainers of that is actually also in Pumas AI as a clinician, right? Again, the people who work on open source do so many different things, but if you find someone like, hey, I'm looking for a clinician, and they just happen to also like to work on the same open source stack, it has beneficial, synergies across the company. And so, this is who you find here, more on PDEs. Also, people work on Julia's linear algebra system and statistics libraries and optimizers, and also the people who build and support Julia's documentation system, right? So again, because again, a company is a lot of things, report generation, all these specialized tools. And so things that don't look like differential equations, they're actually supported now through this company that built software on top of the open source tools, right? So I think, now with retrospect, 5 years later or so, we were kind of thinking at the time, should we open source or should we close source it? I have a lot of open source ideals. Would close sourcing this piece hurt the open source ideals? I think from this figure alone, I can very much say, we've been able to do so much more open source because of making this one specific piece, closed source, because we knew that we wouldn't get contributors back. In fact, it actually helps a lot because a lot of companies in pharmaceuticals, it's very difficult for them to be able to give a donation to an open source community, but they can buy software. All companies are buying software. So if they're buying software from the group that is also hosting the people who are also doing the open source contributions, they know that they're supporting open source. And so there's this like kind of, oh, we like you guys and we want to use your software because of this open source piece and because of this. So it's helped the company, but it's also helped a lot of these other organizations and the people in there that wanted to support open source to have a outlet that is, if I know that if I'm supporting Pumas, I'm supporting the open source as well, right? And that really has helped a lot. So then what is JuliaSim and what JuliaHub is doing, and how is that furthering Julia and SciML as well, right? So in this timeline, a lot of what I did in my graduate school work in my first startup was building out Pumas, and again, that started as like grad school work that then turned into a company, and I was a founding member with the 2 founders being clinicians at University of Maryland. And so that kind of ran its trajectory until about 2021, where I was talking with Viral Shah at Julia Computing, now called JuliaHub, where he's saying, okay, what is the next thing that you'd want to build? And I looked at him and said, okay, I think that we need to do new system modeling software because, I look at the space right now, like with Modelica tools and such, they're great, but they're not progressing to where I want them to go. I want to do this with scientific machine learning and such. So great. That's when I made the change in about 2021 to start building what we call JuliaSim, right? So, and around that time, then we started to build this story, and where we are right now is we've had, our Series A funding round for 25 million. Then we had a supplemental with from Boeing, and it's AE Horizons X, which specifically for doing this in industrial tools. And so, you're kind of looking at the people involved here, like automotive and aerospace industries, you can kind of get a sense for what JuliaSim is really targeting in terms of users, right? So what JuliaSim is it's this kind of simulation engine where you can put together in a graphical user interface a model. Like let me kind of show this a little bit. Right, you can put together a model where you have these pre-built model components, and then there's there's a language behind it, which is this JuliaSim modeling language. It's a lot like the Modelica programming language. Where then when you click the run button, it's able to run these physical simulations and give you results. There's a lot of specific to the domain kind of things that we could talk about, how it's cloud-based with automatic, parallelism and such. But the core idea here is it's a graphical modeling environment, right? So, and so how does this have to do with the open source at all, right? Because I don't build GUIs at all in the open source. Well, the fundamental thing here is that all the models that are being developed are differential algebraic equation models. And so the underlying engine for how this is run is all using our open source, continuing tools, where there's a continuing research from MIT, building out new methods. There's contributions from Pumas AI, continuing to improve the fundamental solving capabilities. And now here's a new thing that's contributing to the same open source core, but a very different application, right? It has these graphical user interfaces and these pre-built model libraries that are now targeting it towards specifically aerospace industries and automotive industries, right? And so the key thing there is that the people who are building these models need to have knowledge of how these tools work, but it's a little bit different, right? Instead of working on the solver itself, the company then builds things like libraries for battery systems and HVAC systems and multi-body systems. They build a digital twin of a car, and the solver that's being used inside of that model of the car is the open source piece, but now we have some of these proprietary pieces on top. And you can start to see the synergies there where, well, everyone that, people who work in the open source then probably know how to optimize these models a lot, because then they know the entire stack all the way through. But it's a very different target where the number of people who are really looking for, say, for a specific refrigerant model for an HVAC system is a very specific kind of person who, once again, we realize it's not the kind of people who are making these open source contributions. It's not the academics and the mathematicians who are interested in the numerical methods, right? It tends to be this very specific group that is asking for, I want the specific battery, I want this specific HVAC system, I want them to already exist, and I want them in a graphical user interface so I could just tie them together and get a simulation immediately. And so there's a synergy between them, and it's built on the open source components, but it is a proprietary piece that is in extending it. So that way we can make inroads into these industries. So it's helping the open source piece grow into being used in these industries by solving one of these core problems that requires, more than just working on solvers, right? It's building out the graphical user interfaces and all the things, and having specialized expertise around, HVAC systems and all this stuff around it. So what we've done then with JuliaSim, if you kind of look at this, you might know, for example, tools like Dymola, right? That Dassault Systems builds, or AimSim. What we're then doing is we're building out a system along those lines, but then we have a lot of new features in terms of integrating machine learning into these graphical tools. And so the product is this graphical user interface that scientists and engineers in this domain would readily understand, readily be easily able to pick up. But the way it works behind the scenes, all the new features and such come from using this open source software. And now, one of the nice things that we have as well is we have this connection where even if you can build a model graphically, right, we have a way such that it automatically converts into code. And we show you this code because, well, the code that it's actually is using to solve things is really well documented because, again, that's the open source piece. And so we've then turned it into this feature to be able to say, hey, look, if you want to know if you want to be able to say, take the results of the graphical user interface and, tweak it yourself by looking at the underlying code that's being run. Well, that's the Julia code. It's already being documented and everything. You want it? We can generate it for you, and we know how to make these VS code integrations and such because we've done this for the Julia programming language already, right? So it's kind of this complementing what we've done in the open source with this portion that is very specifically targeted at these industries, solving some of these solving some of the problems that they need with these pre-made models and a graphical user interface to be able to help them adopt the system, whereas it's still using the same core utilities that we continue to work on um, underneath the hood. So, and there's also a major piece in here that is, so I kind of talked about how, there's some key differentiators and how, we're progressing fast because, it's not just our organization building the core and building everything else. By having this piece be open source, right? We have a much larger development community on our core solver network than we've seen with any of these other tools because it's just hard to get it's hard to ever fund a compiler. It's much easier to fund, oh, let's make the new HVAC thing because our sales team shows that, we could get these new customers from this new feature, right? But just the core compiler of just, oh, can you just fix bugs for a little bit? It's hard to ever find someone who wants to do a huge investment into that. So having this core piece that is then, again, shared between these companies and open source and being used by open researchers just makes the whole system more robust and develop faster. And that's really kind of been giving us an edge in our development speed in this space. But then at the same time, why is this company needing to exist? Well, there's also a lot of other pieces that are required for anyone to be able to use it in industry, right? Which is these pre-built model libraries, specifically in certain areas, but also a lot of things to do with regulatory handling. Because again, pharmaceutical is not the only industry that has regulations. You also have, for example, what I'm showing here is DO17A, DO330 with DAL-A, right? These are terms in the aerospace industry that people talk about where they say, oh, I can only use a software for building a control system of an airplane if it is DAL-A compatible, right? And that has many very specific requirements on the way that the software is being developed and its certain tools and such, and also it needs like a company backing the process to be able to go through the certification. And this is what we're able to then provide as part of JuliaHub, right? We're able to say, hey, look, we don't just have an open source solver, go use it. We have HVAC systems and automotive models and aerospace models, and we're doing this process to make sure that you can use it in a DAL-A, DAL-B, DAL-C, DO178 environment with these regulations that are required to actually be able to use it within, companies that are building airplanes, and same for automotive and such, right? So so again, there's a synergy that is like, oh, the people that are building the open source tools, we want Boeing, Airbase, and all these really cool, Tesla companies to be using all these things, but they can't use the software unless it actually satisfies the regulations that these industries have. And so by being able to have this company then that's there to be able to make sure that the pieces built on this satisfy the regulations, then everyone that's involved in the open source is, oh, that's so cool. Tesla's using it, kind of like idea, right? But then there's no reason those have to be different people, right? The company can then be built and funded and hiring from folks who are part of this open source community to make them be a part of this process that improves the adoption, right? And so I think I'm kind of getting to the end here. So there's a lot of things around building neural surrogates and how we, a lot of the machine learning integration that we've done in the open source space. We've then brought this to the graphical user interface to say, oh, here's cool new utilities where you can drag a neural network in. And the reason why this all works is because our backend is all SciML compatible. And so this is the kind of stuff that we then, work with, for example, the Williams racing team to be able to show like, oh, hey, you can do so much better machine learning if you integrate physical modeling with it. And all this comes because, again, the core math for how this works is one of the biggest research topics at the MIT Julia Lab. And then making it so that way it's robust software and making it so that way it's working with the graphical user interface. That's then what we do with JuliaSim and JuliaHub, the productization. And then this is what's actually able to bring it to being able to be used by Formula One companies. And so that's how, at the end of the day, this JuliaHub piece is how, here's a picture of me actually with George Russell, I think he's like one of the top 5 F1 drivers, and JuliaHub is our logo is on the car of the Formula One team, right? This is how we've actually made major inroads into, really cool industries, right? It's not passively hoping that someone adopts the open source software. It's really, taking that step to say, what's required for open source for adoption of these new methods, right? Well, it requires a team that's actually going to guarantee certain things. It requires a team that will work through the regulations and such, and that could become a full-time job that you do along with continuing to work with the things that you know and love. And so there's another example here of working on a car catapult, but I do want to make sure I have enough time for questions. I think my final piece here is if I just went through today to be able to say, like, who in the JuliaHub are open source developers, right? Here's an incomplete list, right? And saying that this is an incomplete list because this is just the number of people in JuliaHub that you'd be able to point to. If you went to an open source conference, you'd be like, oh, I know what package you work on, right? These are people who are like major contributors. And you can see that, the 4 people who built the Julia programming language, you hear people who work on the Julia compiler, people who work on, the fundamentals of arrays and the package manager and the compiler and PDE libraries and deep learning libraries and the CI/CD systems that they use to be able to test every single piece, right? And the notebook systems and such. All of this is being, ran and maintained because of this closed source software that we've been developing on top of the open source, right? And so again, I think I'd be able to say, especially now with all this, I'd say the evidence here, by making the right things into products, I think we've been able to greatly expand the open source community and give people who are strong contributors of this open source tooling a place where they can go, where they can continue to work on that open source, but also build out tools on top of what they were building that would utilize the open source that they did, right? Because those are then the pieces that are required to bridge into specific industries, right? And so I gave the example of Pumas, which is, it's just differential equations applied to drugs. But no, you need specific analyses, you need specific reports, and you need very specific things. Pumas AI is then the company that takes this open source and develops these things on top of it, where a lot of the people in that company are also the people who build the open source underneath. And so they're excited that, it's now not just it's not just, I work on differential equation solvers, but I work on the differential equation solver that Moderna used for the vaccine, right? It's that step that's actually really cool. That wasn't random. That was done purposefully and also then with JuliaSim, getting all these things used by Formula One and everything, these final pieces that are on top of a differential equation solver, but making those right things products, we've been able to then, have a system where as people are graduating, as people are moving out of the postdocs, the major maintainers of these libraries could have a long time sustaining home that could continue to fund them. So hopefully that tells you the story of, the Julia open source ecosystem. Again, this is not everything going on in the Julia open source ecosystem, but I think a lot of people would say that these are a lot of the big entities. And, this is the story for why do we build closed source software if we also are into open source? I think that it describes a lot about how the right products have really benefited the open source community. So yeah, thank you.
Thank you so much, Chris. It was fantastic. I had quite a few questions that you answered with your presentation, so I have more questions, but first I would like to open up the floor for the questions from our audience.
All right.
And since we have a smaller group, feel free to use your audio if you would rather do it that way. Chat always works.
Hey, again, hi, Chris. Thanks for the presentation, really, really insightful. One question that comes to mind is just, it seems that a lot of these packages have been developed, as you say, through time, and there are like people that are super knowledgeable in it. How can someone start contributing in this open source environment? And again, knowing that there is already a lot of background and it's already well advanced, so what's the best way to start?
Yeah, so there are multiple ways to get involved. I think that one of the things that has helped for a lot of people is we do have a lot of people who come up through the Google Summer of Code training, right? Now that's for more younger folks. I'd say most of the folks that do that are PhD students or postdocs, right? But people at that stage that are, are really versed, are like, oh, I've, done a lot of research and I built my own little scripts that works on my computer, but now I want to work on a larger open source package that people use. Right, we get a lot of these summer trainees. We work with them directly to be able to help them make their first major contributions. And a lot of these people then stay afterwards to be a lot of the core maintainers. So, if someone's watching this and like, I really want to get into open source, I would say get in touch with us about the Google Summer of Code program or the other, Julia Seasons of Contributions programs. We also have, let me just go to the website here. If I go to SciML.ai, and we have in the community tab here the developer programs. We run many developer programs, such as a small grants program where someone can take one of these. These are projects that we think are budgeted for about a month. And so we say, hey, look, there's a bit of a bounty on if you want to work on neural PDE parsers or operators or PDE benchmarks and such. So these are some they're not huge bits of funding, but these are kinds of things that we say like, oh, these are kind of bite-sized projects that have a bit of funding involved with them. If you want to kind of try to really get in the open source system, you pick up one of these projects and we can hold your hand through it and really kind of use this as a, we get something out of it because these are projects that we've seen as high priorities, but also, we'll it's not huge payment for your time, but it's like a nice incentive to get some of these projects out. So I think that a lot of these developer programs that we do, the small grants program and the fellowships and Google Summer of Code, these are where we've actually seen most of our long-term maintainers come from. If you kind of just like, okay, I just want to make a few contributions and just kind of get into this myself, I think the best way to do that is to just get into the community. If you go to julialang.org and you go to the community tab, you'll see that there's a lot of these community spaces. For example, the Slack has about 15 or I think 16,000 people who are a lot of developers in this space. They go to the Slack. I would recommend joining the Slack or the Zulip and talking with some of the folks there. As you start to talk with some of the people, you're when you go to these places, you're talking with the people who built the packages, and so they'll tell you all the little details and whatnot, right? So that's one nice. I think if you start getting conversant with all the folks involved, that's one really way where you start being like, oh, I saw this bug, and then someone makes a comment that's just like, oh, if you just do this little change, you'll fix it, right? That's the kind of thing you'll throw into a chat, and then you just go, my first contribution will be to take this bug fix that they said, I don't have enough time to do this, right? You add a few tests to it and then you do that contribution, right? That's a very strong way that we've also seen a lot of people join. There's other talks that I've given, for example, on if I go to YouTube, it's like developing Julia packages, right? There's a talk that I gave a long time ago on, here's how you develop Julia packages, here's how you fork it, here's how you, do run the tests and all that, right? This is a piece that I'd point to if you want to know a lot of the workflows along with that, along with, for example, modern Julia workflows. Modern Julia workflows is a series of blog posts and best practices that shows how do you write Julia packages, how do you contribute to them, and as a blog post that stays a bit more up to date. I'll say that my YouTube video from 4 years ago is a little bit out of date. It still uses Atom as the code editor instead of VS Code, yada yada yada. Those differences happen. But whereas this stays up to date in terms of showing you like, here's how you work with the package manager, here's how you make a pull request, and here's how you do all the test writing and such. So these tools together, plus some of the developer programs and some of the chat rooms and such, that should hopefully be able to get most people up to speed. And then, as I mentioned, if you're a PhD student or a postdoc at that level, and you're like, oh, I want to take what I'm doing and also start to take that then to software that thousands of people are using. I want to put my work out there. These things like Google Summer Code are a really good transition program to learn that piece as well. Hopefully I covered everything there. It was a very long-winded answer to the question, but
Thank you.
Chris, we have one question Well,
All
we
right.
have 2 questions, as a matter of fact, in the chat.
All right, let me.
For the sake of those who will be watching this presentation via the video recording, could you please read the question first?
One comment here I think I'd like to highlight is, yeah, the high overhead fact of grants is a surprising factor to many who are new to doing research within academia. Yeah, I think that this is something that when you become a research scientist or professor, like this is one of the things that you then learn at that stage where yeah, it's actually pretty common for a university to take 60% of the grant, and then about another 20% of that is going to tuition, where it's nice that the students don't have to pay tuition, right? But so someone is still paying for it, and that's the grant funding that's covering it. So at the end of the day, a PhD student doesn't get that much of a wage, and you don't get that much grant money out, right? So it doesn't fund people for very much money for very long. And this is why if you talk to a lot of professors, they're like, oh, I have to write a grant every week or something. It's a very difficult process to keep going. Yeah, and I think that if people who it's something that's known. If you talk to any professor, I bet you they'll tell you like, oh, the overhead is too high. I have to write grants too often, right? It's the hidden secret about academia. If you search for it now, you'll see hundreds of articles written about this. But it's for people who aren't in the academic system, nobody knows about it. But it is a major factor that is really affecting open source. Is there a preferred method to reach out? Yeah, so the preferred method to reach out is, again, if you go to the julialang.org, and if you go to the community tab, you'll find a lot of these forums. Like for example, on Discourse, you'll find, for example, that there's thousands of people talking here. I'm on here all the time. I think if I pull up the stats here or something really quick, it'll tell you something ridiculous. Let's see. Yeah, so if you want to reach me, I guess I'm on here. I spent 45 days total of actually reading, and have read 170,000 posts here. So if you want me to read your posts, I can guarantee you, if you go to this Discourse, I'd be happy to read it, what you're posting. Or if you go into these chat rooms like the Zulip and Slack, these are great places to chat as well. You can also send me an email if you want. That's for more private discussions. I think that a lot of things that go on in the open source community, you aren't the only one to have the question, right? So if you're like, oh, can someone walk me through how does this part of the ODE solver work? This isn't, you might think that that's a private question because why would anyone else ask? But no, there's actually, for every question that you have, many other people ask the question, because like some students like, oh, I want to modify it for my research. Can you tell me how this part works? If you just ask in the chat room, you'll probably find like, oh, here's 20 people who will respond that have looked at that part and find it really cool. They could explain it to you. Or if no one knows how it works, then it's like, oh, this many people all have the same question. Let's make a video that describes it. There's a lot more that goes on in the community bit. So I'd say you could reach out through email, but I would suggest reaching out through these channels as well. You'll probably get a better answer faster. Let's see. Given that the majority, so most of the maintainers are not at Pumas AI or JuliaHub, right? There are a strong number of the maintainers, and okay. The question here is that given the majority of SciML and Julia maintainers come from MIT, JuliaHub, Pumas AI, does this create governance issues for the open source projects? It turns out that by building this healthy background for a lot of contributors, you do get a large number of contributors who are funded by these organizations, but it turns out that it's not even close to a majority, right? If you look at, for example, the current group that is maintaining, like for example, Core Julia, right? If I go to JuliaLang, if I go to the Julia GitHub itself, right? And you look at the contributors, right? There's over 1,000 contributors. If I look through this, like this is JuliaHub, 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 right? Because these are the original founders, and JuliaHub, not JuliaHub, not JuliaHub, not JuliaHub, not JuliaHub. What's JuliaHub, not JuliaHub, right? So not JuliaHub, this is Pumas, right? So there's, so there's this kind of mixture, right? There are a lot of really strong contributors who are now part of these organizations and they will stay really strong contributors because their full-time job allows them to, right? And so they will probably be some of the highest committers and such. But you will find that actually it's not actually a majority, right? So you have people, Stephen Johnson, he's also at MIT, but he runs his own lab, which is separate from the Julia lab. Tim Holy's at a different university. Katie's at a quantum computing, or actually she's in the quantum computing division of Amazon, right? So you just find that you just get what I think what ends up happening is you don't have people tend to leave the open source community as often. It's more so when they're saying, hey, if I'm having trouble finding a job that lets me stay in open source, all of those people, you're able to kind of keep them in the ecosystem, right? Because you'll also be one of the first places that they ask for a job as well. So I do find that we in a lot of these organizations, we're not the majority, though we are a strong presence in all of them. Does that end up creating governance issues? I don't think it necessarily has so far, because for a lot of the things we just kind of work a lot in the open. And so there's a lot of other voices and opinions. Now, it does mean that a lot of the prioritization ends up being towards maybe some of the things that these companies need, right? So, very specific ODE solver features like modeling toolkit as the foundation for JuliaSim has gotten a lot more people to be funded through JuliaHub than some other pieces, like, for example, uncertainty quantification that JuliaHub doesn't use. So some prioritization goes on there, but I don't think it's necessarily an issue, because I think a lot of the people who have a full-time job that to work on open source, the fact that they have a full-time job that allows them to work on open source kind of wouldn't even exist if the company wasn't there, right? So it's not that it's really kind of forcing the prioritization in a certain area. It's that it's that you do get a lot more resources in certain areas so it's not moving resources, it's creating new resources, I think, right? But yeah, I think that it is something that we do have to kind of look for in, for example, a lot of the open source organizations, and we do have to kind of say a lot of the time, like, oh, hey, what are the things that people who aren't us are looking for? Let's make sure that we balance that in a lot, and let's not just have this discussion on our own. Let's have this discussion for prioritization of, say, SciML or the deep learning libraries. Let's have this discussion in an open chat form, so that way everyone's interests that are not within the company are also there, heard, and also recorded, right? P.S. I worked on FluxML as a student, and I love the whole Julia ecosystem. Yay, awesome. So yeah, so I think yeah, and it's something that you have to be actively conscious about, of course, right? Because it definitely could go in ways that are not advantageous to the open source ecosystem. But I think that one of the reasons why it's worked out so well is because a lot of the people that we have that are contributors in these companies, they were contributors to the open source organization first, right? So they kind of have this foundation where they kind of understand, like, oh, I love this open source project. I don't want to kill, I am a part of this open source project. Now I'm a part of this company that allows me to continue working on it, but I'm not going to just suddenly 2 months later just say, I don't care anything about the astronomy guy. Like, you're talking with them just 2 months ago, right? You already know everyone using the software. So I think by having this already having built this love for the open source community and its usage, really make sure that the people that have been going to the company keep these kind of viewpoints in mind. I think that helps a lot. Yeah, given that academics and research industries maintain these software, has there been a slowdown in the development of packages used by CS software engineering people, like web development frameworks? Yeah, I mean, and the other part of this question is because I never hear of Julia being used by big projects and industries in web development. That is a big point to be made here, right? That I mean, I kind of talk about my personal journey, right, and things that I work on. I work on a very specific kind of thing. Everything's related to numerical differential equations. And so a lot of the big organizations for Julia, it's because they're kind of these organizations that I've built up or been, become a major part of, right? A lot of them are founded around these kinds of numerical differential equations pieces. So we do, kind of have this bent where, oh, a lot of the people who are being, a lot of the people who have a full-time position also tend to be people who are working on nonlinear optimization, machine learning, and, these very mathematical simulation topics, right? But it isn't everybody, right? I think, if I point to, for example, the Julia Lab has all sorts of things, but even in terms of like the documentation systems and such, right? The main maintainers of those packages, become are and people who work on Markdown support, right? These are people within Pumas. And why is that the case? Well, because a lot of what Pumas needs to do is for reports generation. And so things like being able to help people build PDF documents is a large part of the productization. And so the people who do documentation and such, they're exactly the kind of people that you'd want within that company, right? And then also, people who work on the GUI tools like VS Code plugins, and again, documentation tools. A lot of these people are within JuliaHub. Now, again, there's not as many of these people because JuliaHub as an organization doesn't build web frameworks. And so that has kind of lagged behind, right? This is actually something we have to consider a lot. It's like, oh, if we're to start building some web tools, right? The JuliaSim thing is a GUI that is working on web tools. Do we also want to build a web framework, or is this too far away from our company's goals? It would help the Julia community in terms of building the web framework, but can we take this on right now, right? And I think that what I would say about that is, we have to kind of focus on what we're good at. I know I'm good at differential equations. I know nothing about HTML or, I know nothing about CSS. In fact, if you ever see me create a website, it's the worst looking one ever. So what I would say is that if you want to build out, say, Julia web frameworks, one thing that you might do is you might create an open source software and a company on top of that to then continue to drive it. And that's actually what the Genie folks have done, right? So if you look at what Adrian has done with Genie, the Genie framework is a Julia web development framework. And it actually has a company that is trying to drive development, and a lot of the maintainers of the Genie framework are funded through the Genie company, right? So this is something where, that company is kind of in an earlier stage. It hasn't really found its full market yet. I don't think it's only been like a few years or something. So, I think that it'll need some time to be able to grow into what it is. But I think that it definitely could happen. But yeah, I think, there is this kind of like yeah, I know this bit, so I'm going to help it a lot. But, what about other things? What about, standard machine learning? What about large language models? What about web development? There's so many different topics that you can do. And so I think the Julia ecosystem has become strong in a certain piece. And part of that is because that's what Julia is good at. And part of that as well is because we've been able to build these organizations with the productization and stuff on top of it because we know this area very well. But other people should definitely build other companies with other products on top of other open source tools for building out all these other spaces as well. But yeah, I think there is a downside of I mean, for example, Julia has not done as well in statistics, and you could point to that to be able to say, oh, well, you don't have anybody who does statistics in the MIT Julia lab, and it's like, yeah, I wouldn't really be able to be their thesis advisor if they were in that space because I work on differential equations and machine learning, right? So there is that downside, but I think while it's a downside, it's more of a thing of, one person, one organization can't do it all. Let's help other organizations, figure out how to build a full process. So that way, if someone wants to be able to build a company in Julia that, is using the statistics libraries and funds it all, the roadmap now, right? So this talk exactly is sharing that roadmap to you. I think, yeah, I think that's most of the questions there.
Yes, you covered all the questions in the chat. And I know we're well over time, but hey, long format is a thing, right? 2-3 hour podcasts are very popular these days. So I will ask one question.
All right.
The last one. Here it is. Chris, you have a PhD and also 2 startups under your belt. And I'm curious, did you ever think of being an entrepreneur or did you become one out of necessity? And then to add, I'm curious if you have any advice for someone who is considering making a leap out of academia into industry.
Yeah, that's a very good question. Because yeah, I mean, and hopefully kind of came across a bit in the story here where, yeah, my original background was, I work a lot on these differential equations. And, when I was approached by people who did pharmacology, so the way that I found the pharmacology space was my original differential equations work was because my PhD work was in mathematical biology. So a lot of the numerical solvers that I worked on were for biological applications. And so it's very natural that, the main biology that a lot of people care about is humans. And so people who worked on human biology kind of got in touch with me about the tools I was building. And so when I learned about a lot of their problems, I go, oh, I can build you a software that does this bit, right? And so I thought this was just going to be, oh, this is another thing, what I'm doing. I'm going to go to, after I finish my PhD, I'll probably go to a postdoc where I work on this. And, maybe this pharmacometrics is just where I do my next open source software, right? Again, I had a lot of closed room discussions with a lot of large pharmaceutical companies. They basically just said, like, we can't use it unless you pay millions of dollars for FDA evaluators. Oh, and can you work on this file format reader? And oh, what about report generation? Can you make it so that way it matches my company's colors and follows this format? I was just like, I can't do all this myself. Like, and also I want to spend more time on the differential equations. There's other people who like to build PDFs and make them all super cool. There's other people who work on file format readers and data. Like, this isn't the stuff I do, right? And so, and also where am I get the money for the regulatory things, right? And so it very quickly to transition from like this, like I didn't ever intend to become an entrepreneur, but I just kind of realized with, the people that I was talking to, the pharmacologists, there's a lot of discussions of like, hey, this could actually be better if it was a company. Like, if we want this software to work, this part should be a company, right? And that was a very difficult transition for me to make, right? Because again, I really love open source software. I built 200 Julia packages or something at this point, right? Like, I love open source software. So like, I was like, had to think about it for a little bit and say like, am I going to do this? But once once I realized like, oh, like, okay, we could have this kind of licensing per month, and I start writing my own grants and everything, I just started to realize that there's so many more open source developers that would be had if we just build a full system for this. So we took the leap, and it was the right leap to make. And so then when I had the second shot for, what am I going to do? Am I going to, just build another academic lab, or am I going to, build a software company? My choice ended up being, I think the software company would be the bigger thing to, be able to make larger contributions to open source and everything around it. So I had no intention to become an entrepreneur at first, but I think that from my story and everything, I think that there's a very clear justification in the end where with hindsight, it was the right thing to make this jump, and it achieved all the goals that I wanted and more. So if anyone wants to make that jump into industry, I would say that, we're not the only companies that have done this, right? You can see, for example, Posit, they build a lot of a lot of this open source tidyverse and the R source packages, right? And they're a company built on that, right? There's a company for Anaconda, which is the package management system in Python, right? There's these companies that support the machine learning libraries like, Facebook and such. You might want, if you're really interested in open source and you're also interested in, what am I going to do after academia? You might want to, talk with some of these groups and just say, hey, look, would my skills be useful? And again, I think, we found every single time that it's just like, oh, someone who already knows how all the software that we're using works is exactly the kind of person we want to hire. So boom, automatic, obvious, right? So I think that if you want to make that transition, and a lot of times it's not even a 100% transition, I would say, in a sense, right? Because it's like, oh, you still get to work on, if you're contributing to like this deep learning library and this company's using it, then you can still probably do some contributions there, right? You need to work out the IP rights and everything. It can be different per company, but it's a really nice transition then, because your skills are then immediately useful to this company, but you still have these connections to these things that you've known and loved for over the years. So I'd recommend I really like having done the transition to industry. I still have an academic position. I love the research, but there are a lot of issues with growing, the growing long-term maintaining things within the academic system, and that's of course its own whole topic. But yeah, so I think that if you're hesitant about making the jump, start talking to people who are using the same software as you, and I think that you'll find that there's a lot of these connections that will then start to excite you, right? Of like, oh, I've been building a deep learning library, but have you ever thought of that? Hey, the way that your own movie recommendations on your computer through Netflix, have you ever thought about making that better? While you work on your open source software, you could be the one to do that, right? And so I think if you start talking to enough people, you'll find the exciting connection and you might make that jump. And I think it was the right one for me.
Thank you so much, Chris. Your impact on the Julia community is truly impressive. And thank you for sharing this knowledge. You're definitely paving the way for new models and defining the meaning of open source sustainability. So thank you so much for your time. And I also would like to thank all our attendees for your interest in this topic. I hope it was useful. It sounds like from your feedback in the chat. This presentation will be posted on OpenTeams YouTube channel in the coming days. And please continue this conversation by connecting with our LinkedIn group. And